the second lesson of grade 9 mathematics, that is polynomial. All of you know that there are so many branches in mathematics, but in our school syllabus we deal with all four of them. They are numbers, algebra, geometry and statistics. Hearing the term algebra, some of you may feel that it's so boring. It's all about remembering or memorizing some identities like a plus b all square equal a square plus 2ab plus b square. And even some of you may feel that the letters x, y and z are dancing in front of you. Am I right? But how many of you know that our great Indian mathematician Aryabhatta already gave the identity a plus b all square equal a square plus 2ab plus b square. Then why can't we try to study algebra in an easy way? Let us start to study algebra in an easy way and try to become little mathematicians like little Ramanujans and little Shakuntala Devis. Are you ready? In this chapter, we shall start our study with a special type of algebraic expressions called polynomials and terminology related to it. We shall also study two important theorems, remainder theorem and factor theorem, and their use in factorization of polynomials. Last year you studied some of the identities and their applications. This year we shall study some more identities and their application and their use in factorization of polynomials and evaluation of some sort of algebraic expressions. Then what about the application of polynomials in our day-to-day life? Polynomials can be used in financial planning, tax and economic calculations, problems involving construction and material planning, scientific problems involving or including gravitational acceleration problems, and so on. In the service industry, the healthcare support occupations such as nursing, psychiatric and home health aides requires a knowledge of polynomials and their uses. Before proceeding further, let me help you to recall the points which you have already studied the previous years. All of you know that there are two types of expressions, numerical expressions and algebraic expressions. Numerical expressions are expressions having only numbers, but algebraic expressions are expressions having at least one variable. That is, algebraic expressions are expressions having at least one variable. A combination of constants and variables connected by the signs of basic calculations is called an algebraic expression. A combination of constants and variables. Then what do I mean by constants and variables? Yeah, constants have fixed value, but variables do not have fixed value. Its value can change. Let's consider some examples. 2x plus 3y minus 4z is an algebraic expression. It is an algebraic expression in three variables x, y and z. The second one, 5x square minus 4x plus 6 is also an algebraic expression. It is an algebraic expression in one variable x. The parts of the algebraic expression separated by the signs of addition and subtraction are called terms of the algebraic expression. Therefore, 2x is a term, 3y is another term or the second term, and the third term is negative 4z. You have to mention the negative sign. The second one, 5x square is the first term, negative 4x is the second term and 6 is the third term. Each term has two factors, a constant factor and a literal factor, or a numerical factor or a numerical coefficient, and a literal factor which is also known as variable part. Parts of an algebraic expression separated by plus or minus sign are called its terms. Terms have already I told you, terms have two factors, a numerical factor and a variable factor or a literal factor. The numerical factor or numerical part is also called the numerical coefficient. difference between a letter denoting a constant and a letter denoting a variable. Constants have fixed value in a particular situation, or its value cannot change in a single problem. But the variables can keep change, or it can take any value in a particular situation. Consider x plus by plus c, where x and y are the variables. Here a, b, z are the constants. Now, last year you studied about the degree of a term. To get the degree of a term, we have to add the exponents of the variables present in that term. Again, to get the degree of a polynomial, where you take the degree of the term having maximum degree. That is, the highest degree term degree is considered as the degree of the algebraic expression, or the degree of the term having maximum value is considered as the degree of the polynomial. The degree of the term of a polynomial is the sum of the exponents of the variables present in it, and the degree of a polynomial is the degree of the highest degree term present in it. Now I hope you could recollect all the points which you have studied so far. Let me move to the other topic, that is polynomials. I have already told you that polynomials are special type of algebraic expressions. That means all algebraic expressions are not polynomials, but all polynomials are algebraic expression. Then what is the speciality? Let us consider some of the algebraic expressions. 2x squared plus 3x minus 4 is the first algebraic expression. Just check the powers or exponents of the variables in this first algebraic expression. For the first term, the power of the variable x is 2. For the second term, its degree is 1. For the third term, that is negative 4, its degree is 0. Consider the second one. Here, the first term is 3x. The degree of the first term is 1. The second term is negative 2 root x. You know that root x equal x to the power 1 by 2. Therefore, 3x minus 2 root x plus 5. In this expression, the power of the second term or the degree of the second term is 1 by 2. The third one, 5x minus 4 by x plus 3. The second term, check the second term, 4 by x, negative 4 by x. Know that negative 4 by x equal negative 4 x raised to negative 1. Negative 4 x raised to negative 1. The last one, 5x raised to 5 minus 4. Here, the degree of the first term is 5, degree of the second term is, you know that it is 0. Know that negative 4 equal negative 4 x raised to 0. The first one also, you know that 2x square plus 3x minus 4 plus 4, 2x square plus 3x minus 4, we can write it as 2x square plus 3x minus 4 x raised to 0. I told you polynomials are special type of algebraic expression. In an algebraic expression, if the exponents of the powers of all the variables are whole numbers, then we can consider it as a polynomial. Polynomial is an algebraic expression in which the powers of the variables must be whole numbers. Therefore, in the second and third case, you know that the second term, negative 2 root x. Here the power of x is 1 by 2. 1 by 2 is not a whole number. Here negative 4 by x, that is equal negative 4 x raised to negative 1. Negative 1 is again not a whole number. Whole numbers starts with 0. 0, 1, 2, 3, etc. are whole numbers. Therefore, in this case, the first and the last are polynomials. The second and third are not polynomials. Is it clear? Polynomials are algebraic expression in which powers of all the variables must be whole numbers. That is the condition we have to check. Now the next point, how to define a polynomial. We can give name to polynomial based on the variables present in them. Consider a polynomial having only one variable x. We can call it as px. Another polynomial having the variable y, we can name it as qy or py or ry. That means px, y, z represent a polynomial having the three variables x, y and z. This year we are going to deal with polynomials having only one variable. An algebraic expression of the form px equal a0 plus a1x plus a2x square plus a3x cube plus etc. an x raised to n is called a polynomial in x over real numbers if a0, a1, a2, a3 etc. are real numbers. That is px equal a0 plus a1x plus a2x square plus a3x cube etc. plus an x raised to n, where a0, a1, a2, a3 etc. are real numbers and n must be a whole number, is called a polynomial over real numbers. We can classify the polynomial in three ways. First one on the basis of the numerical coefficient. Second one on the basis of the number of terms present in them. The third one based on the degree of the polynomial. On the basis of the numerical coefficients. If all the coefficients present in a polynomial are rational numbers, we can call it as a polynomial over rational numbers. If all the coefficients are real numbers, we can call it as a polynomial over real numbers. Now, on the basis of the number of terms, I hope you studied last year that point. The number of terms present in a polynomial is only one. That is, polynomials consist of a single term are called monomials. Polynomials having two terms are called binomials. Polynomials consist of three terms are called trinomial. And polynomials having four terms are called quadrinomials. Generally, we use the term polynomial. Poly means many. Then on the basis of the degree 1 polynomials are called linear polynomials. Degree 2 polynomials are called quadratic polynomial. Degree 3 polynomials are called cubic polynomials. Degree 4 polynomials are called biquadratic polynomial. Then, just consider a linear polynomial. Degree 1 polynomials are called linear polynomial. Its general form is linear polynomials are degree 1 polynomials. Its general form is ax plus b, where a not equal 0. If a becomes 0, you know that this expression becomes 0 plus b, that is b. B is a constant. Now for the quadratic polynomial, the general form is ax square plus bx plus c, where a not equal 0. Now for the cubic polynomial, the general form is ax cube plus bx square plus cx plus d. For the biquadratic polynomial, general form is ax raised to 4 plus bx cube plus cx square plus dx plus e, where a not equal 0. Now let us go through some examples to illustrate the applications of the points what we have studied so far. Just give one example of the following. The first question, binomial of degree 5. You know that binomials are polynomials having only two terms. Again, its degree must be 5. Therefore, just try to give an answer we need two terms. Again, the degree of that expression must be 5. Okay, I will write an example for a binomial of degree 5. 2x raised to 5 minus 4x. 2x raised to minus 4x. See, there are two terms, therefore it is a binomial. Again, the degree of this binomial is 5. The second question, a cubic monomial. Monomial means polynomials having only one term. It's cubic. Cubic means its degree must be 3. Therefore, just we have to write a term with degree 3. Say 7x cubed is an example of a cubic monomial. A biquadratic trinomial. Biquadratic means polynomials having degree 4. Trinomial. Trinomials are polynomials having 3 terms. Therefore, biquadratic trinomial. It is an example. 4x raised to 4. Therefore, degree of this polynomial is 4. 4x raised to 4 minus 3x square minus 2. There are 3 terms, therefore it is a trinomial also. I hope you could get the point. The next one, 0 polynomial and 0 degree polynomial. 0 polynomial. From the name itself, it is clear that 0 polynomial's value must be 0 only. Yes. 0 polynomials are polynomials in which all the coefficients must be 0. But 0 degree polynomial, you have noted that any constant, say 5 equal 5x raised to 0, negative 10 equal negative 10x raised to 0. That is, all the constants are 0 degree polynomial. 0 polynomials are polynomials in which all the coefficients must be 0. But constant polynomials are 0 degree polynomials. Then the next question, what about the degree of a 0 polynomial? Yes, the degree of the 0 polynomial is not defined, but non-zero constant polynomials are degree 0 polynomials. How to find value of a polynomial? You have studied how to evaluate a polynomial if the value of the variable is given. The same method. Value of a polynomial px at x equal a is p of a. We have to substitute the given value in place of x. Consider the polynomial px equal to x minus 5. You know, p2 means value of the polynomial at x equal to. Here we have to substitute the value 2. 2 into 2 minus 5. That is 4 minus 5. 4 minus 5 equal negative 1. Therefore, if px equal to x minus 5, p of 2 should be negative 1. Consider this question. If px equal to x cube minus 13x square plus 17x plus 12, find p2 and p negative 2. To get p2, we have to substitute the value 2 in place of x. Consider the problem px equal to x cube minus 13x square plus 17x plus 12. Find p2 and p negative 2. p2 equal 2 into 2 cube minus 13 into 2 square plus 17 into 2 plus 12. That is 2 into 8 minus 13 times 2 square, that is 13 into 4 plus 34 plus 12. 16 minus 52 plus 34 plus 12. First of all, we have to add all the positive numbers. That is equal 16 plus 34 plus 12 minus 52. That is 62 minus 52 equal 10. That is P2 equal 10. Now to get P negative 2, know that to get P negative 2, instead of 2, we have to substitute the value negative 2. P negative 2 equal 2 into negative 2 all cube minus 13 into negative 2 square plus 17 into negative 2 plus 12. That is 2 into negative 2 cube is negative 2 times negative 2 times negative 2. Negative 2 into negative 2 into negative 2 gives negative 8 minus 13 into negative 2 square is positive 4. 17 times negative 2 is negative 34 plus 12. Again, negative 16, negative 52, negative 34 plus 2. All the negative terms together we can add. Negative 102 plus 12. That is 12 minus 100 is equal negative 90. I hope you will be able to solve questions from this topic. But you know that practice makes perfect. You will try to solve the questions given as assignment. Thank you.